That's actually wild. Yeah, I'm like, ran out of heap space. Oh, that can't be good. But that's my disk space running out. I don't know why this one's not giving. Maybe I just have it open in something. I don't think so. I do have a lot of tabs of just random stuff though. It looks like one of the, or both of the Twitch chat overlay things died too. That's funny. But we can fix that. Okay. Are we good? I hope we're good. Cool. Hopefully at least everything is partially back to normal for now. Sorry for the technical hiccups, and we are going to proceed. So I'm gonna try to rebuild because we literally just ran out of heap space trying to build my program in the middle of the building. And so what I wanted to talk about real quick was, okay, we're gonna see what structures get filled up thanks to these, and then we need to store that data somewhere. So this code, as far as I understand, will create these groups. So if we look at group is a tile group class, and the tile group class, or struct in this case, is a rectangle with a range, a collision range, and a vector filled with tile render data of tiles. And tile render data contains a tile sheet, a pause, tile sheet pause, tile ID, layer ID, a group pointer, which, what is a group? What is tile sheet data? Tile sheet data is a tile set name, a first GID, a pixel, and tile groups. What are tile groups? I guess that's what the group thing I saw earlier was, right? So I guess it's just a pointer back to its core group, so it itself knows where it's supposed to go. So what I would like to do is let's actually take a look at this data so we can get an idea of how we want to organize it, right? I'm going to breakpoint once we try to load in level 4-1, our very large stage, which we can use as like a good test to figure out what we have to do with this. Okay, we don't need that right now. Maybe later, but not right now. So loading into 4-1, let's go ahead and breakpoint once we hit this line of code. Or actually, once we hit the end of this. So we notice that they are also sorted, so that's actually kind of important. If they're sorted, then we can store them in the file and read them sequentially, and they'll already be pre-sorted. Okay, so let's take a look at these structures. This is what we're trying to figure out. So, foreground tile groups, again, they have a range which contains a position and a size. They have a collision range. They have a vector filled with tiles. Each tile has a pause, tile ID, layer ID, tile sheet pause, and a tile sheet, which contains a name, ID, and tile color. I don't think so when it comes to the tiles, I'm trying to think here. Yes, we will have to store this information, but I don't know about the tile sheet. The tile sheet, we can grab that information. I don't think that's necessary here. Although storing it wouldn't be a big issue, but I'd imagine most of these are the same, so it's like redundant data. But not necessarily, right? Well, actually, we should make an assumption that everything from the same tiles... No, they won't necessarily be from the same tile set. If these are groups, not necessarily, right? Okay. But yes, we can see there's plenty of these, so that's the kind of data we're storing. So let's start figuring out a structure to handle this. I'm just going to keep this up right now, and we can go from there. So maybe a new window would be helpful here, as I was saying earlier, where we can just work here and keep something popped up on another window to reference. I don't know if this will stay up. I hope it stays up if I like pin it. I think it will. Just like this. Excellent. So, over here, we're basically going to make some kind of, I'm gonna call it the tile group saver. Now, the question is, can we optimize this on top of that? Because it looks like afterwards we have to go through all the groups and we have to do something else. So it's like the split up data, the iterated tiles makes new tile groups split up. So it's like there's two things happening with these tile groups at the same time. Does that mean we wait till here? I think that's what it means. We actually wait until the next loading phase. It's like there is a secondary adjustment to all the tile groups afterwards, so we do want to wait, I think. And you can see that takes up quite a bit of time, but all these are now further split up from what it appears. Like the structure is definitely larger. And so, yeah, we want something like that, I guess. Now it's interesting that some of these, the collision range is like a size of... Well, that's not the size, is it? A size of 0, 0? I wonder what that means. Why is the size 0, 0 in the first place, right? Does that really even make sense? I don't know if that even makes sense, really. Like, you can see a lot of these, the size is 26,21, 26,19. Is this like the number of tiles? Really makes me wonder. Like, maybe it is. It's kind of strange. Either way, it does work out, so we're gonna use that. My guess is maybe these tiles were picked out and now there's nothing left in them really that works. But we can see here these tiles are indeed like connected. They're different tile IDs. They're at a certain position. So why is the collision range size small? But the size is not. Maybe collision range means something else. Maybe we're supposed to ignore it because we look at the actual range. It's like, oh, okay. But maybe the collision range is a modifier of that range. Which would be fair, right? Like, I think there's a correlation between how large that size is and how large this size is. There must be. And there must be a reason for that. We're not going to worry about that for now. It might be like how far up you have to be or something, or how far down to trigger it. So making a structure that can hold this information after we've done all of this tile group processing, which it looks like that's the only tile group processing we do. I kind of thought there would be more, but I guess that's the bulk of the work. So let's make it possible for this to actually be optimized. So let's go into the Adventures in Lestoria class, and let's create a new class that makes sense here. Maybe tile group cache? Tile group data? I think tile group data is fair, but maybe tile group cache is more clear, if that makes sense. Should it be a new class with the new header file? I feel like it should, just to be on a clean slate, avoid having to touch this main class even further. For something that's a little unrelated, it will also reduce compile times if we have to change something. Changing Adventures in Lestoria.h affects the entire build system. It touches everywhere in the game, so that would not be a good choice to put something so volatile. So let's go ahead and make a new header file and call it tile group cache. We might even call it like tile group save data. That's not a bad idea either. Tile group save data.h. I think that's a good name to go for. It's pretty accurate to what we're trying to describe here and do. Let me just copy real quick a license. And we can get started. So we'll start with a class called tile group save data. So we're definitely gonna have to store these structures right here for each one. Also, they are sorted, so they get put into a very specific order, which makes sense, and we're gonna follow that order, which means however we store these, they have to remain in that order. So I guess for save data, we're gonna make a vector of these and put everything we need inside of them. So ideally, what we should do is we should accept a foreground tile groups or upper foreground tile groups thing here. So accept a standard vector tile group, and we will modify it from there. That's going to be our constructor. So we're going to make our own public, oops, that's a very loud public. It's very much in all caps. So tile group save data. We're gonna make it accept a const standard vector tile group reference. So where does tile group come from? Tile group comes from map.h, so that's what we're gonna include. Now, does Adventure in Lestoria use map.h? The CPP does. I don't think we'll need it in the header, so we should be good with not having header conflicts. So it includes map.h for the vector tile group. And we need to accept like a place to store this data. So on top of it being this, let's save it in a file, right? Let's accept a standard string of a file name. Call it the save file name. And then when we're constructed, we're going to do some things. So let's start with, I didn't mean to continue running the game. That's not good. Oops. My bad. I must have hit F5 by accident, but we can get back there easily. That's no biggie. It'll take a minute, but it will breakpoint at the same location. It's the same stage. And so let's start by iterating through this tile group. So we'll say for const tile group reference group in tile group. And really this should be plural, tile groups. And so we are clearly going to open a file and store this information. So we're going to need an output file stream. Save data, which is going to consist of opening a file under the name save file name. And then we're going to start piping information into this file. I think the data should be stored as one piece of information per line. I think that would be fair. So for example, for the range, we would do save data. I think that would be the most flexible. If we split them by like new lines or something, we could use another character, but new lines make the most sense to me. So let's do save data group dot we don't have a lot of public members here. We have to make this a friend class, so that would mean adjusting map dot. How does that happen? Why do I keep doing that? I hit like Control S. I guess saving continues it. Maybe we don't need to do this. I don't know. That's kind of annoying, but maybe we'll be okay, right? We just have to store all the data, and we kind of know what the shape of that data looks like now. In fact, I could argue we can go one step further. We do kind of know what this looks like because we can do a... I've used this before. I'm trying to find it real quick. If you go to a class, I think there's a tool you can use. Outlining? No. There's a tool you can use which just shows you all of its members in a kind of like visual way. I don't recall where it is though. It's been a minute. Oh, here, memory layout. Which kind of shows you all the members in this kind of like visual style. So you can see here we got the tile group range, which is a rect int. We got a rect float. We got a tile render data structure. I think if you go further in, you can drill into this as well. So that's fun. Oh, we can look at it like this too, which I think is also nice. So, in fact, it's so nice, I might just bring it over here for a little bit. Hehehe. Okay. So that'll be handy when we write this up, because we're essentially writing something to save all this information. So that'd be nice to have. So since this is a Geometry 2D Rect, it's going to contain a pause. Oh, yeah, we also have to do the friend thing. So tile group is inside of map.h, and tile group data.h wants map.h. So I have to separate implementation from definition now. And I always have to. I always try to leave it for later, and it never works out, right? Also, this header file is in the wrong folder. I'm going to drag it up, because I can. Very silly, but it's supposed to go there. So we're going to make a CPP file. That's not what I wanted. And this will be called the tile group save data. Okay. And we're gonna essentially move everything we just made over here. And then all we have to do is include tile group save data.h with all that information. That way we don't need to include map.h here, because we can just say, well, we still need to know what tile group is. But now, oh, let's think about that. Actually, we still need to know what tile group is. That means if two header files that need to know about each other are using the same data type, it means the data type needs to be moved into its own header and source implementation on its own, or at least its own header, so we don't have to reference recursively between two header files. This is an issue we run into commonly, so maybe we don't have to do this quite yet, and we might not have to. I'm gonna leave that out for now and just delete it. It might not be necessary. Let's try fix this. So tile group is the problem class. Tile group is right here. We need to move it into its own header file because two files need to know what this type is. However, these two types also need to know what each other are via this class. So getting rid of that dependency by putting it so we only have to rely on tilegroup.h is the correct play. So I'm going to insert those in there, and then we just have to get its dependencies into here and see if there's any more dependencies we have to move over. So we need a OCUtil geometry 2D for the rectangles. We need tile rendered data, which is inside of map.h. So if map.h needs tile group and tile group needs map, wait, does this need tile group? I guess that's the next question. Does it even care? It says that struct tile group exists, but this is a forward declaration. So it actually doesn't need to know the full definition of tile group. That kind of changes things then. Tile group didn't actually have to be in there the whole time. Tile group can just be part of the tile group save data class. And here, because this is a raw pointer, we can just say tile group exists somewhere, but we don't have to actually include that file. So we can put tile group in here, get rid of tilegroup.h in there. So we're just going through what is commonly referred to as multi-file hell, because knowing which header files are connected to which, how you have to split them up if you're having like issues with stuff referencing other stuff, that's important. So we only needed a map for tile group, and tile group is in here now locally, so we don't need that anymore. But I see we do need tile render data, and tile render data is in here. So we still need map.h. Do we need tile group save data? I forgot if we did. I want to say we don't, right? I don't think we do. Put that back for now. It's just tile group is in here. Yeah, so what's the issue? I don't think there's any more issues then. Oh, we have to make this a friend class, that's why. I think you can do that without actually... Do you actually have to include for a friend class? I feel like you don't. I think you just have to put the name of the class. So if we want to access everything inside tile group, which is literally right up here, we can by friend classing it. We're actually in the same file for it now, so it actually kind of works out funny enough. But if I'm friend classing it here, does anything else need access to this? Does anything else even use this? Find all references. Well, we know Adventures in Lestoria.cpp does, but it gets it through all these getters. So we are friend classing it to access these members directly. I guess because we're just directly interested in those members in the first place. So group.range .x. So like I said, saving everything on like one line at a time, I think would be the most flexible. Although I would argue not necessarily. Like, if we can save them like back to back to back, that would also be nice. Also, this is not x. I think it's pause.x. Actually, VF2D has an output for this. Although it's not very readable friendly. Like, we want to go to an x, right? So an x, a y. Now my question is, do we write this like this? Because if we do, don't we have to write it in binary? If we write it in binary, we also need to fill in gaps, I think, right? If we just write like the number 10 and then we write the number 300, how do we know those set of bytes are for that specific range? The question is, does binary writing fill in like the entire range of that variable? That's what we need to find out. So what we're going to do is we're going to open up example. We're going to try to write a binary file with 2 or 3 ints in it. But that also means something like a string is questionable, right? Like, we would have to serialize it in a way that's complicated. So then my next question is, do we end up going with an OLC data file? That might be fun. I mean, that would work, like, honestly. And then we can just iterate through all the keys of them. I kind of like that idea. Because at least it's human readable. It's got parsing. We can put things on one line. It removes a lot of the complexities when it comes through parsing data, rather than just writing, like, every single thing on a new line each time. We can put each object on one line with all the meaningful things in one list. And maybe that's like... that's pretty much ideal for how we originally envisioned this being, is make it so that util data file format is flexible enough for anything like this. So I kind of like that idea. Let's go that route. So we're going to instead bring in a data file. And we're going to call it the save data. And it's the same constructor, I think. Well, not a constructor, but we call save data dot write. I guess when we're ready to write, we do that. And we write whatever information we're interested in. So we can say, like, save data. I guess it would just be one after the other in a row. Like, we just write each line, each on its own line. So it'd be something like standard format group, and then you start labeling out all the groups. Because you need to have initially like a variable name, so group 1, group 2, group 3, etc., etc. Why is my cursor missing from the editor? That's very annoying. I'm gonna like reopen it. Okay. Cursor's back. Group whatever. So we're gonna initialize with a, let's say, a size t index. We will increment it as we go. And because this is a vector, all the elements will be ordered in the same order. So this is going to be comma index, and that's going to determine the initial place we're writing to. And then we're going to say will be equal to, or we're going to do set a value. So we'll do like set int group pause.x, and that's the set value 0, so we can keep setting other values too. set like 0. In 1 we put in pause.y. And so on and so forth. We have all these like items we can set inside of it, right? That's essentially what we're doing. I don't even think we need to include a name, to be honest, if we want to. We can just start right from here, from the get-go. But I think it would be nice to have them grouped like this. That way we can just keep them all organized in a nice, pretty format. So we got X and Y, and then after that we have maybe we got the size values, which are the next things to store for rectangles. Use the wrong shortcut. So those will be 2 and 3. Now, we can see this keeps incrementing here, so we're going to say this is like the item index. And we can start that as 0 and just keep incrementing it. Because we don't have to manually type all these out, I think. It would be reasonable to just say item index plus plus. But then we have to keep track of how many there are later when we read it back in, unless we just write everything in the same order. So maybe we'll do it that way. The next is the collision range, which are real values. So we say, okay, group.collision range. And these are going to be real values. And then after this, we have tile group tiles. So it's going to be a vector of tiles. And so each tile will have to store like the tile ID. I think at the very least that's what we have to do. I don't know if we really need to do this part though. Because one, it's got the tile sheet, pause, tile sheet, pause, tile ID, layer ID. And this is like per tile. But I guess it also includes like all the other stuff related to tiles. So maybe this is important. So since it is, then we're going to do that part next. So this is, I'm just going to make a label here, tile render data. So now we're on that. So for tile render data, we first accept a tile sheet data class, which comes with a tile set name, what the first GID is, and the tile color. But I feel like the tile sheet data class we can retrieve from somewhere. I think it's the class we were working on earlier that we ended up like consolidating. If I go to defines.h, maybe not tile, defines.h, but maybe inside of the Adventures in Listoria class itself, I think I have something related to tile sheet data. Yes, it's called getTileSheet. So if we need to retrieve anything about a tile sheet, we can do it through there. So storing the tile sheet here I think was just a convenience. I don't think it actually matters in our case, because we can just get it at any point in time if we know the map and tile ID. So the key here is just storing the tile ID. That's actually a very important point to bring up, is there will be some redundant data in here, I guess just for convenience. So we're going to store the pause for sure. So that is group.tiles. So we have to iterate. We have to say for tile render data, or I guess this is a struct too, so it would be const as well. So for tile render data, tile data inside of tiles. So this would be group.tiles. We're now going to iterate through all those. And what we can do is we can form another index inside of here to represent all those objects. So maybe call it like tiles, tile rendered data, and then the name itself. So this would be a standard format. Basically like this one, it's just we're going one level deeper. Tile, I'll just put tile, yeah, tile render data. And we need another index specifically for that. So in here, we'll just do for size t tile render index. And we'll make sure we increment that every single iteration. Hi there, Alex Severia. Welcome. We're currently in the process of serializing some data. Well, serializing in the sense of storing in a file, so we can kind of cache it for loading the game faster. And replacing this with the tile render index. And then we will set those ints inside of there. We can reduce the verbosity of this a little bit by storing these before setting these. So it'll be something like data file reference group data. I think that'll reduce a little bit of the pain of writing all this right here. Replacing all this with group data. And then going a step further and drilling down when we get down here by saying this is the tile render data, which is just the group data with an additional lookup in there, replacing these as such. That'll reduce a lot of the extra typing we would have to do. Excellent. So yes, we'll keep going, although we have to set a new item index, so local to this is another item index for just for this loop. Yeah, that should be correct. And so we're setting now the tile data pause. Tile data dot pause x and y. We need to set the tile sheet pause x and y. Also, pause is a VF2D, so these need to be real values. The second ones, though, are integers. And this is the tile sheet pause. Presumably which index it is within the tile sheet. And then the tile ID itself, which is also just an integer. And the layer ID. Apparently there's a tile opacity as well. I'm not certain I use that for what I think I use it for. But let me take a quick peek. What does this get used for? It looks like the tile opacity does get applied, but where do we set it? Where do we use it, essentially? Render tile, permanent foreground rendering. Oh, this is how we fade stuff out. So this is like a variable that just changes in-game. We don't have to store it necessarily ourselves. It's just needed to make the actual tile work later. That's just how the structure works. So far so good with this. Now we're back out here and we're doing the tile group variables. So we got another integer. This is the group's tile or min x, min y, max x, max y. And then we have the fade factor. Again, I don't know if that's actually required. I think it's just used in the actual game to adjust everything. So I think this is all we need to actually set up our structure like so. So now that we have all the tile group save data we need, I think we're ready to assemble this structure and see what it looks like in game. So we're going to now do a save data dot write, and we will write to, oh wait, excuse me, it is a static function. So we do data file write to save data, or we write save data to save file name. And with that, we have assembled an entire file that represents all of the tile group inside of an actual file. We've taken that data and serialized it. So now the next thing to do is we gotta test it. So we're gonna go back up to where we render all this stuff. So this is after everything's done. Oh, that's a bridge. So, bridge stuff? Oh, this is rendering, excuse me. I'm like, I thought we were in the loading code for whatever reason. That's the rendering code, which also has so much going on. It's insane. So we get down here, and we're like, okay, now that we're done with all this, our next objective... Oh, is this all messed up now? Why would this all be messed up? Let's see what started all this. Tile group fade time. I guess, I don't know what's going on. IntelliSense is being wacky. It always does. So what we're going to do here is we're going to create a new tile group save data now by including the file in here. So include. Oh, I think this is the issue we ran into. Is if I'm going to include tile group save data in here. Well, no, this is a CPP file, right? It should be fine. Yeah. I was about to say, if this was a header file, we would actually have issues, but it's not, so we should be okay. And so we're going to create a brand new tile save group right here. Right on the spot. And this is going to be the foreground tiles save data. And we're just going to insert let's figure out a format, and let's actually figure out a file structure for this. So we essentially need a folder that is going to store these things, because it's essentially a cache. So we can keep it in assets. I would put it under like map cache, maybe. I think that's a good name for it. What if we want to cache other things though? Maybe cache is better. So let's just call it cache, and we'll go ahead and do standard format. So we're already in asset. I know. So we want to do assets slash cache. But we also want to read it from, say, like an asset pack if we put it in there, right? So that's an interesting point, is this should probably come from an asset pack. So we want to actually read it from there. Do we abstract the asset pack part of this? I think we're supposed to. So sure, we do a data file.write or whatever, but now we have to insert it into the resource pack itself. So where do we grab that? I think that's in defines. Well, we have the pack key, which is not what we're looking for. Is it just under Adventures in Lestoria? I feel like it is. That'd be interesting. Hui Dai Duer. Hello. Sorry if I butchered that. Yeah, I'm starting to think, okay, we have to deal with the resource pack thing. So, let's see how we would do normally, because if we look, actually I think we're seeing it right here. No, that's just data file stuff. Let's go to like... pack. Gamepack.load. Oh, okay, so it's a local variable inside of AIL. Are you static? You are not static. So we would have to get the game instance, which is fine. I think I will need to separate this now though, because we can see here, if I were to include game, that would include Adventures in Lestoria. That includes a ton of other stuff. We would run into issues. I could also just pass the resource pack into here. That would save us quite a bit of headaches. Maybe that is the play. Because then I just have to include also cpixel game engine.h. That would save a lot of trouble. I kind of like that. Keeps the class small too. Cool stuff. Oh, thank you. Yeah, so provide a safe file name, but also provide the resource pack itself. So I don't think this will be const. It's just going to be resource pack. Reference pack. Okay, so then we're back over here, and we're going to say game pack, comma, standard format, assets slash cache slash foreground tile data. And then we can put, I guess, the map name or something after it. So like underscore that, and maybe dot dat or something, dot data, comma, and then the map name. I don't know if I have map name here. Oh, here it is. It's just dot map. So we can do that. And then afterwards, we provide the structure itself. So this is foreground tile groups. So with all that in place, that will hopefully save what we need. And then same for the upper foreground. We'll just send in another structure to do that. Upper foreground tiles. Change the file name to be upper foreground tile data. And after that, we just have to implement it as for the resource packs, which happens at the very end here. After we do data file write, we say pack, add file, and then the file name. Save file name, which hopefully should be all we need. Is the game playable yet? Yes, there is a playable demo, and typically I will, when I'm working on my game, I will be able to build it when I'm not deep in a code mess. So right now we're actually building it. And then hopefully, I'm actually going to breakpoint here in the loading process. We'll actually end up with usable files that cache the tile groups for us. So we'll see how that forms between the two levels we load. And if the data looks good, then what we will do is we'll see if the file exists, and if it exists, we're just going to cache or fill up the data structures ourselves, and then we don't even have to do all of the processing that we've been doing here. So that will be interesting. I'm looking forward to that. And I like this a lot better because it literally uses the loading processes we currently have. We don't have to rewrite a code. We don't have to write an external program to do this. And then we can just say, if the cache files exist, use that. If not, create the cache files. Use them from now on. So I actually really like this. Also, while this is building, I will be right back. Oh, or we just get a bunch of errors. So yeah, we probably got some undefined types to fix up here. So tile group is not defined. Hello? In map.cpp. Is this open or am I just blind? Okay, it's just not popping up. So use of undefined type tile group in map.cpp. So what I do with tile group, I moved it into tile group save data.h thinking it was only used there, but it is used in map.cpp. Now luckily this is a source file, so I should be able to include tile group save data.h. Right? Because we already included map.h, so it has what it needs from there. In theory. And then use of undefined group type tile group again in monster.cpp, which is fine. Again, we just add it. We just moved this type around a couple times, so no biggie. Tile group save data. Okay. Do we have any others? I think that was it. Hopefully that should be it. The name of the RPG is Adventures in Lestoria. Let me pull that up because it can be a little confusing. Oh yes, Adventures in Lestoria. That is the Steam page for it. So it should be built. Let's go ahead and hit that breakpoint. And I just want to take a look at the files it produces, because that'll be the first thing we want to do. It's taking an awfully long time. Dang. Yeah, I forgot in debug mode how much it has to actually do there. Okay, so it should breakpoint here in a second, or it just calls abort because something bad happened. Let's see. String reserve, okay. In prepare level lambda 6. So it's saying string reserve somewhere. Why are we reserving a string? So this is weird. Oh, the map value is corrupted for whatever reason. Hello? Why is the map name corrupted? How did we manage that? But okay. Where does this even come from? It comes from underscore prepare level. We just pass it in, but the map name is dies? Current level equals map. So this function like dies with the current level. So we have to say like get current level instead. Or get current map name, I think. I forget which one it is. It's one of the two. But But yes, get current map name is what we actually want, so it doesn't corrupt in the middle of our... Because this is like deferred loading, so this function only has those variable lifetimes exists until it's done. Like all these add phase calls are just deferred function calls. These are all lambdas, so that's why we're having issues. Anyways, we'll try again. Hopefully it works. So, still having that issue? Is it the same issue though? Let's see here. No, it's a different issue now. Error log says key group 0 does not exist in data file. Well, we're not trying to read it, we're trying to create it. I guess it doesn't exist, that's why. Okay. So we can't just use that syntax to initialize, despite it looking like we can. We have to actually create it ourselves. So it's gonna be like... I guess we're just gonna say set. We have to set something though. We can't just set an object inside. That's weird though. That is very strange because I feel like it was always the case if it would just write. Unless I'm going crazy. I'm gonna look at that error one more time. I don't feel like that error is supposed to even happen. So let's go to debug log. Should be in here. So, oh wait, that's not it. Release debug log. That's not it either. Where does the debug log go? Unless I'm insane. Let me try a PowerShell. Where's the other PowerShell thing? There's supposed to be more. Like, it's supposed to let me run a couple of these. Oh, I did that backwards. I want this one over there. So I can do /read debug log. Okay, so key group 0 does not exist in data file. Well, that is what we're doing, but that's also not the problem. Key group 0 does not exist in data file. Let me think. I feel like it's just supposed to be created on the spot, but it's line 533. Let me see what that file is actually doing here. Line 533 of OCUtil data file says... Okay, if initial... Oh, once step is complete, we assume maps or we cannot open more data files like this. So basically we're saying, okay, they aren't written to by default, so we have to actually turn this off again. I guess it's like a feature that I added to make sure I'm not writing stuff I shouldn't be. So this is for... It's more for safety, I guess you could call it. Now, is this just a local variable? It's a static, okay, so I can do data file initial setup complete is false. Required to write to data files. And then, so basically we created like a lock system where we're, for safety. We shouldn't be writing when we're not supposed to. And then we can set back afterward. Or more importantly, we set it to whatever state it was in before, not just necessarily true and false. What if it's not done? So we just say previous state. Previous setup state is equal to this, and then we set to false. And then we set back to whatever state it was in afterward. To be polite. Because we don't necessarily know if it's actually true at that moment. We just need it to be false, but we don't necessarily know if it was false. We know because the code, the game actually complained about it, but technically we don't know either. So auto hide. Auto hide. Okay, so let's see if it'll actually write the files now that we can quote-unquote write to our data file structures, because they were read-only before. We forced them to be that way. So that's just my bad for forgetting my code for so long. It's an old code base, it's hard to remember everything, right? Okay, so let's see if we can actually hit the cache files saving, and we'll just take a look at what those look like. So we did hit the breakpoint this time successfully. So if we go into assets cache, there are now 2 files which contain all the foreground and upper foreground tile data for our maps, stored like so. Hello Roxa6, welcome. So as we can see, for groups that have multiple tiles, they all get stored correctly. So that's great. Strangely enough, I don't see... I don't see like the other variables. They're supposed to be like group... Oh, I guess they're all just comma separated. Yeah, something strange. I'm not understanding this, because it's like, okay, group 0, right? For example. And then I just have set int. So I guess this is invalid syntax. Like, because normally it'd be like, okay, set an int 1, set int 2. Like, this is what I was expecting, right? But it just turned it into an actual group. So we have to create something underneath here that has all that data for us. So that's interesting, and definitely not my intention. So not only do we put group whatever, then we have to put item whatever after it. So it's inside of there, which is kind of annoying, I will admit. Like, we have to put like a data group after that. And same for tile. Well, tile render data is fine because it's not an object. So if we ever have an object, we have to make something else to hold all the other properties if we want it to be multi-indexed like that. So that wasn't quite right, but it's close. What put it into a group? So this is the OLC util data file class. And the way OLC util data files work is it's kind of like a human readable configuration format, as you can see here. Kind of like a YAML or a JSON file. Very similar idea. It's just JavaX9's version of it. And so what puts in a group is if I just specify, like, we use this like array syntax, kind of like when you're accessing like a hash map. So if you put stuff inside of it, then all of a sudden this is now a group instead of a property, and only properties can hold values. So if you convert a property to a key, which is what happened here, suddenly you can't have it represent any data because it's just... So we can see now it's a little different. Oh, that's not right either. That's definitely not what we want. I just turned... So I have to do like group data dot set int. Wait, no, that is what I'm doing here. Hold on. Something's not right. It's like I need to set data equal to like set int. I have this item index increasing. I feel like that should work. Oh, but then I'm using group data down here. I see the problem. So this is like, I'm gonna separate this variable to like data props to only grab group data. So we're storing that stuff inside of here. So this is now data props. And then now group data with tile render data, blah, 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 will actually be correct. So we just have to regroup all of our files, our data to fit into the correct groupings. So it's a little bit complicated. Did it work? It's getting there. Then we have a Okay, so hopefully this is in the actual format we care about now. Just waiting for it to load. Okay. Come on, game, you can do it. Debug mode is slow, but it's fine. And then, so basically data should hold a set of values, and then we have... I guess my question is, all this will now be in group 0, 2, so it'll be like data, tile render data 0, 1, 2, yeah. Perfect. So this actually holds all the data we need now. I'm like, I was missing a piece of data, now it's up here, so perfect. So we basically serialized all of our pre-map processing into a file, which is great because what we can essentially do now is recover that data and say, all right, now take this data and read it in instead of doing the pre-processing. And we don't have to wait for these map load times anymore, at least a significant amount of load times. So I'm gonna go ahead and, just to get a very giant sample size, I'm going to load in this map, which is the very large problematic map we've been dealing with so far, and just have it run its course. And then once it's done, we're going to write the read function. So we already have the save, now we're going to write the load data function, which I guess I'll make another class because we already have save data, so might as well write load data. What do those tile equals numbers represent? Yeah, they are generated. So basically we just got here in the breakpoint, which is the problem we're addressing. And what these are is, if we look at a map, let me pull up a map. Not that one, that's a broken map. And we look at the tiles here. What the game does is essentially these trees are like in the foreground, right? You expect in the game that when you can like walk behind them, whatever. But you also expect that each of these trees is considered one object. So what this is doing is it's grouping them. That's why we're calling these tile groups, is basically my preloader has to go in and iterate through every tile and say, okay, you found a tree tile, which we know is a foreground tile. We defined all the foreground tiles in our tile sets. That says, okay, find adjacent foreground tiles and connect them together. So then it goes through and it iterates through, kind of like a flood fill algorithm you can think of, and it tries to find every tile that connects together. And then once it finds all of them, it saves it as one object. Great. Do that however many times there are foreground objects. So far, so good. And then, in this game, you want to be able to see behind, like, solid objects that you are behind of. Like, for example, if the player is walking up to this tree, and you walk up kind of above it, you should be able to see, like, behind this. Because, like, if there's an enemy hiding behind this, or something hiding behind it and you can't see it, it would kind of be unfair. So what we do is when you get close and above one of these tile groups, it should like fade out. But sometimes when you're walking around, you might be like here and you might be able to see something over here. So then we group all these objects into one big group. So when we look at those values that were like comma separated, let me pull it back up. The reason why we have multiple is because this is all the objects themselves all combined together. This is like every tile that should all fade out at the exact same time, which might include multiple objects together. So if we just look at, ooh, this is pretty big. It's like half a meg almost. Yeah, this is that map we just looked at, all the tile data. So you can see it is a ton of data, almost half a megabyte, and this is a lot of processing. So we want to pre-process it so we can just read this data from a file. We don't have to do all these calculations, which, as you saw, in debug mode takes a while. But even in release build, it takes a good 2 or 3 seconds, and this is a good computer. Like, I feel like waiting that long to load a level for whatever reason, right, is kind of ridiculous. So we're currently caching this data so we can just read in the raw data and we don't have to do any calculations, to save us quite a bit of time, because file reading is fast. Storing stuff in memory is very fast. So I'm going to make a new class now called load data, and we're going to try to load everything we just read back into memory, and then we're going to make it so if we find an existing cache file, we're going to use that instead. Sounds organized but complex. Yes, this right here is a very complex process. You can see here there are lots of nested for loops. There are lambdas inside here, so like this whole thing is a lambda, which tries to make it more bigger picture. So we're like, okay, this is the general idea of what's going on. If we want to get into the implementation details, here's all the implementation details. So yeah, there's even a go-to here because it is like 5 or 6 nested for loops, so that's fun. There are comments to try to explain what each for loop is for, but as you can see, like, we have to find out if the tiles are adjacent to each other, we have to find out if the tiles are supposed to connect or if they're not. Like, it's rather a complex problem to solve. It sounds simple on the surface until you try to write it. Have I released other games? Not on Steam, but I've participated in game jams, code jams. I've also published a lot of little things in the past. I've been doing the game design creation as a hobby for 20 years, so you can imagine any like creative, they have hundreds, thousands of little toy projects, right? All around the block. Some stuff in almost release state, some things in barely prototype state. So plenty of stuff. But the stuff I actually publish, like if it's small, it goes on itch. This is my first game I'm working on that's actually going to be released on Steam. It is a very, very large project, as I've already explained a little bit of earlier. So I'm excited. It's also been 3 years in the making, so... But yeah, on itch I have some smaller projects, which I've done for... And you can see the demo, it builds to Mscripten as well, so the demo is also on itch.io, on top of being on Steam. But here's a couple of like more finished stuff, but not necessarily as deep. These were... this, and this. These were all game jam entries, so that's fun. Oh, this was 2. This was like my very first like test in Pixel Game Engine, but my very first games were written in GameMaker, specifically GameMaker 5.3, when it used to look like, and I like to pull up this picture a lot because it will have like a Windows XP background. I used specifically GameMaker 5.3a, and yeah, basically when it used to look like this. This is like probably the most popular screenshot of GameMaker you'll find. It's got one of the default projects open, 1945. And yeah, when it used to look like this. Good stuff. And I used to play with that all the time. The idea was I used to only have a dial-up connection, so I figured instead of taking like an hour to download a 3 megabyte game that I would never like play for more than a few minutes, I wouldn't even know if I would like it, right? Instead, I downloaded a 3 megabyte program and just wrote stuff all the time. That was like my logic as like a 10-year-old kid. So that's what I did. It looks so different, you're right. And as Yo-Yo Games took it over, obviously they started to like commercialize them more. They created like a whole site to host your games on. Like that was cool. So I don't even know. Yeah, it's now the Yo-Yo Games archive because it's not even like, wow, they don't even have like a front for it anymore. You literally just have to know what game you're searching for. I can't even think of a game name anymore unless it's like mine, but I don't even think it's on here. I'd be surprised if it was. Oh. Yeah, there it is. This is one of my old games. It's literally on here. It got a rating of 3.0 by 4 users. I guess it's still on here, which is actually insane. Blast from the Past, that's 2007. Wow. That's actually insane. Does it run? Like, that's my next question. Can it even run? Okay, thanks, Windows Security. Oh, wow, it actually runs. I think it opens full screen, though, and yeah, okay. Can I... Okay, good. F4 unfull screens it, so you can just kind of see here. God. Look at that. Isn't that beautiful? This is what we make when we're, like, just starting out, you know? The goal was to touch these eyes, and as you progressed, yeah. Isn't that great? We used MS Paint back then, because that's what every kid does the first time they're making graphics, right? Yeah, that's great. But yeah, you have to, like, find the letter I in a sea of other letters, and touching the other letters typically reduces your health, but does other things. Yeah. A lot of my other more, like, interesting projects ended up being hosted on a website I used to run, but it's not visible anymore. So I might do something with those eventually, but I still have all the files on box.net, I think it is. So I can literally go there and grab the source files. I have a Windows 98 computer with GameMaker 5.3, 6, and 7, so I can load up all my old stuff on the Windows 98 computer if I want to actually play them or recompile them. It's just like fun little things to consider in the future. It's kind of a little backstory of me, I guess. Alright, so we got a constructor. We're gonna kind of do the same idea here. Okay, so we're done with this. Get rid of that. So to answer your question, yes, I have made quite a few other games in the past, ranging from very silly things to actually pretty impressive little like demos or games I'm working on. So, oh yeah, huge nostalgia, that's for sure. Oh man. So we're gonna pass in the resource pack again because we have to load from it. We got the load file name, the expected file name we're gonna read from. Or is that how I want to do this? Let's see. Yeah, I guess it is. And then we need a reference to the tile groups, but it's not going to be const because we have to now populate the tile groups. So we'll use the tile group save data as a reference for how we're going to repopulate them. First, we need to, well, open our file. So we're going to have a data file again. This time we don't have to unlock the data file because we're just reading. So this is the read data. I'm just going to call it data, honestly. Data.read. And this is from load file name. Okay. Thanks, that's an inspiring story. I'm glad you liked it. But about 6 or 7 years ago now, I found well, I was kind of transitioning from like, oh, I used to use GameMaker a lot. I want to find something that's simple that I can just like build fun stuff with. So I was looking around. I think there was a wiki with just like random game engines, right? And then I found somewhere it was just listed like OLC Pixel Game Engine. I'm like, that's interesting. What's that? And then I end up like Googling it and I find out, oh, hello. Hi, Tim Kaine. We don't need you right now. I ended up finding this guy, JavidX9, who wrote the OLC Pixel game engine, and I ended up joining their community, and I just kind of kept an eye on it. And about 6 years ago, or 5 years ago, OLC Pixel Game Engine 2.0 got released. It's now preparing to have like a 3.0, which is going to be a lot more feature-rich, uses a lot more of the GPU, of course, but still involving pixels. And what came out with 2.0 was the WebGL stuff. So I'm like, ooh, I can build my games for the web. That's kind of cool. So then I grabbed it and really started playing with it. And that led me down a whole journey of learning how to C++. And this guy's channel does feature a lot of projects involving using his engine to build like all sorts of things, from an NES emulator to 3D graphics to just silly things. Serializing, deserializing structured memory. We're actually doing that right now with his data file, so we're literally using what he built, which is very awesome. So that's kind of what kickstarted my whole C++ journey. I used Pygame for a while to build like Python games, but I made it very like a GameMaker-like because I was coming from GameMaker. So I'm like, okay, let me just write a bunch of functions like instance create, make a create event, make a step event, make a draw event. Like, I basically tried to replicate the structure of GameMaker in Pygame, and I tried to do it here too, but eventually you kind of lean away from that and realize there are other ways to write game engines. So in the end, we settled with our own thing, but it took a while to separate myself from GameMaker brain to other language brain. Oh, yes. Think of it more as like a framework. It's not even really a game engine. It's like we can put pixels on the screen. We have a couple functions to interact with mouse and keyboard. Everything else you're on your own. Like, even this save file stuff, this is actually a utility that was built to aside from it. It's like a whole separate thing. So, which is kind of nice. That's what I did too. Very awesome. Yeah, like, I guess at first it's like, it's hard to transition out of, like, GameMaker brain. I ended up learning GML, so I'm like, at least I had that, but then trying to get into other programming languages, I want to stick with what's familiar. So that's awesome to hear. I think it's very common to do, especially when you've been stuck in one engine for so long and you got so comfortable with it. So data.read is going to return, well, first we need a data file to load. I keep forgetting this is static, so this is more like data file, : read. That's static. And it takes a resource, or not a resource pack, a data file structure and a load file name, populates the data file structure, and then we're going to read from there. So we're now going to take our tile group's vector, and we're going to assume it's empty. Actually, should we assume it's empty? We would hope it's empty. If it's not empty, what should we do? Should we clear it? I feel like that would make sense for a load function. It's like we want a clean structure. So I'm just going to force a clear if it's not already cleared. Then we're going to read in all these values. So we're just going to start iterating through our properties. We need it to be in order though, so we're going to use the ordered keys function. So it's going to be in for const auto key comma size from data dot get ordered keys. If we didn't care about order, then we would use just the regular iterator, but we actually care about order this time because it's a vector and the tile group data was sorted, as we saw down here with these last two standard sort calls. We could do the sort ourselves after we load in the data, but I think we'd rather take the cost of sorting up front because we already pre-sorted it. Is there a particular reason why you feel the need to write this game on such a low level? I've considered it, but it seems like it would take so long to implement game design ideas. I think it's because I find the process of programming and problem solving fun. If you don't enjoy that aspect and want to just focus on game design, then your reasons for choosing an engine with more features would be very valid. But I think I just enjoy the process of programming. My favorite part of game design, or the game design process, is actually writing the features of the game. Like right now we're writing something, so we're writing a lot of code, and that's fun. But to me, designing the actual game, designing all the assets, the sounds, the music, the story, the art, all that is not as fun to me. It's not necessarily boring, but they are requirements for the game, and I don't find that part as interesting. So to me, the programming is the most fun. So the more programming I get to do, the more fun I have. And that's really all it is. Yes, it does take longer. I do get the benefit of I have way more control over my game engine, which is kind of fun. Sometimes that's beneficial, sometimes that's not beneficial. You might try this engine out just to learn programming? Yeah, it's very nice. And if you want to just like try it out without doing anything, it's literally like just a single header, by the way. You pop the header in, there's an example at the top of the file, and then you just run that and you're ready to start building. So it's literally that simple. But there's also this site, which hopefully it loads, called PGA Tinker. It's like your, what is it called? It's like your compiler explorer of the OLC Pixel game engine. So you can literally load this up because it supports WebGL. And it's taking a minute, but once you have it up, you can choose just your classic demo. Be like, okay, run that. And it just has a couple of draw functions, and it's just like, oh, you got your interactive thing. You could be like, all right, well, let me try a... It's even got some tooltips for you. So you could be like, okay, well, what's a fill rect? Fill rect accepts position. So you end up figuring out, okay, let's put it at like 30-30, right? Your size, let's make it like 20, 20. Let's make it blue. You can literally just play with it in here, and then you can compile it and run it. It's literally just running the same engine I'm using to build my game, but you can just try it out. So there's a blue rectangle. And maybe you want a yellow outline for it, so then you do a not filled rectangle. Voila. And you just start playing with it. You can start writing code to move stuff around. I forgot it's offset by 1 because it's like WebGL scales things funny, so you get that. Well, actually, I think that's just how it's built. Yeah, the fill is on top, so we need to flip that. Outline should be above the rectangle, so drawn after. There you go. And then you get a yellow rectangle. Delete all the other junk if we want to. Maybe keep the clear color though. Yeah, so if you want to just give it a whirl and see what features it has, you can go play with it from here. If you want to add keyboard input, you can start doing something like, okay, store player pause, right? VI2D pause started at 0, 0, that's the default. VI2D is just an integer vector, 2D vector. You can be like, okay, if keyboard or get key, OLC key. We can do left and right? Like A and D. So dot pressed. Well, no, we want held, not pressed. Then you go left, otherwise you go right. X, or pause X minus equals, let's do FELAPS time, because then it'll be based on frame rate, times, let's see, let's go 50 pixels a second. Do that for right as well. So A and D key, pause X plus equals, run. I didn't mean to hit reload, but it does save periodically, so my stuff is still there. I'm convinced now? Yeah. And then if I press A and D, oh, we have to make our position adjusted based on, you know, our... Can I multi-select in... It's supposed to be... This editor is the same editor that Visual Studio Code uses, so you kind of get that Visual Studio Code stuff, so... Can we move now? We're based on pause. Pause is... Oh. Did I mess up? I said if get key A be held, pause X minus equals FELAPS time. Oh, it's very slow. It's also an integer, so we're doing decimals. Let's do VF2D so we have the right type. Let's do... I had 50 times here. I must have deleted it by mistake. Try that again. Yeah. Yeah, there you go. You have your little, like, way to run your test games, and then you can actually get it for Visual Studio. Again, it's literally just grab the header. There's, like, a repo for it. OC Pixel Game Engine header. You can be like, hey, I'm gonna start using this. So you grab this, literally can copy paste it. Then it's like, okay, how do I use it? Bam. It's got the example right here. You can copy paste that into a source file. Hit build. Should build. Requires C++ 14 at least, I think. But a lot of the utilities require 17, so I recommend building on that. And then if you wanted to explore the functions, all the public functions are near the top, of course. There's your drawing routines. You can draw pixels, lines, circles, fills. You have decal versions, which draw stuff, images via the GPU. Then you have your utility functions. You can get screen width, screen height, get your elapsed time that passed, get window sizes, get mouse, get keyboard. You have your 3 functions that you override on user create, update, and destroy, and you start building your project out of this. And that's pretty much all you need. There's some more advanced stuff too. You can touch the pixels and textures directly and update things to the GPU. You have layers, so if you want to do like kind of like a more classic like SNES layer system, you have the ability to use layers and draw stuff on specific layers. You have a built-in little debug console. You can do a text entry mode. Fun stuff. It's even got a couple of crude like hardware 3D drawing that interacts with like 3D pixels. 3D pixels, what am I saying? 3D positions. You like it? Yeah, give it a whirl. See how you like it. Check out JavaDX9's videos if you want. I'm a shill for his engine, so I always will be. I think it's fantastic. If you want to learn programming, it's a great way to start. You get stuff on the screen fast. Like, you saw I was literally just typing some things, trying it out. It's fun. What's my favorite Love Live series? It's just OG. First gen. But I also like, the second series. The second season, sorry. I don't know anything about the other generations of Love Live. So, I'm just old school. Oh, shoot. I was supposed to put dinner in. I forgot. I was supposed to put food in the, what do you call it? Wait a second. I think I left my groceries in my car. Oh shoot, that's gone bad then. Oh no, I feel so bad. Oh no. I just lost some food. Feels bad. What'd I lose? I lost my ziti, and I lost my... What else did I get? I lost almond milk. Oh man. Yeah, over 4 hours ago now. Well, I just lost money. That's okay. Alright. Yeah, I just got a notification that I was supposed to put dinner. Whew, alright, anyway. Let's see here. So, we're gonna iterate through the keys. Firstly, we're gonna iterate through anything with group in it. I guess I just kind of start going through it. So, we're gonna get like group whatever, and then we're gonna see if it has a tile render data inside of it. And we're also gonna see if it has data inside of it. Everything should have data at least. So it's gonna look like... I don't know where Visual Studio Code went, but... Oh yeah, we got into this. Let me go back. So... I'm gonna have to... Yeah. I'm gonna have to take care of the dinner stuff soon. So we'll call it pretty soon. I just want to get this started, and then tomorrow... I think our plan to make this all happen will pretty much be ready to go. We seem to be on the right track, so that's good. I really like how I did this. So here's our cached file. We'll always open this with this. So it'll always have a data member, and then it'll have a certain amount of tile rendered data members that we'll just iterate through. And yeah, but this will just iterate through each one. We don't actually care what the name of it is. We could use the number as a check to make sure, hey, does the index of the size of the vector match up with the index? But we're going through it anyways, so let's first see if key is equal to data. Then we're going to write that into group.range. So we're basically gonna deserialize this now. So this is the order that we sent in our information. So essentially, these will be gets. And then we're looking at specific indices, and we're moving these variables to the front because we're setting them now. So it's gonna look something like this. And the item indices we will increment like before, starting from item index 0. Okay, so this will be data key. Data key, because we already know it's data, so that's good. And then the group itself, presumably when we do this, we're creating a brand new group inside of tile groups. So we'll do an emplace back, and we'll end up getting the object we create from it. I assume I can do an empty constructor, but let's make sure. Or if it has a constructor, we're gonna have to populate it. Okay, it's just a struct, so we can initialize it empty. It's got no constructor. And then... Oh, but you know what? I'm noticing we have an insert tile function here. So we might have to invoke that, because we're presuming that when we have a new tile, these are going to adjust, but we stored these. So that's interesting. I'm starting to think maybe we should have just stored the tiles and only the tiles. That's a much smaller data set, but we already have most of the data we need for this. We might as well just populate it. I think I like this better. Let's just stick with this for now. So the object we get out of here, tile group, reference, new group. And place back returns the object that was emplaced. So that will be what we start adjusting. And what is wrong here? Inaccessible. Oh, this is a new class, so I'm gonna go to... where was it? Here. And just add a friend class for load data, so we can access those members. Okay. I'm gonna put an else statement here, and so otherwise we're going to say, just to make sure, he has to start with tile render data. And if it doesn't, then something went wrong. We don't really care about which tile render data it is, we're just gonna place back into the tile render data as well. And if we don't find anything, then let's just error out, because we literally could not figure out what we're doing here. Warning. Unknown key. Key found while trying to load cache for file. Load file name. Does that not work? Improperly terminated. Is it? Expand? Let me see. How's it improperly terminated? What did I miss? That is properly... I think IntelliSense just wasn't caught up. Just being silly with me. Anyway. Alright, good luck. Glad to talk to you about the engine. Hopefully you have a good time. Thanks for watching. We'll see you next time. And I'm about to call it 2. Let me just get these in real quick, and then tomorrow we'll see if all this works and implement all the actual, like, using this file to read everything in. But we're pretty much almost done with the implementation at this point, so that's nice. So we kind of do the same thing here. We're going to do new group. We're going to go to the tiles, and we're going to emplace back a new tile. I think it's a struct as well, so we should be able to just grab it. Tile render data. Tile data. I'm going to say new tile data. Okay. So I'm going to take all these guys out. There we go. Move all you all out here. Change these to get. Remove the commas. Make a new item index that increments inside of here. Change these to new tile data. And then we don't need this. And these are from data. Well, not data, data key. Well, let's see here. How does this work? So, oh, it's the same thing, actually. They're all just one level in. If they were multiple levels in, I would have to nest these, but I don't. So that mostly fills us up with every information we need. There's just this, which is data after the fact. Wait. Oh, we lost some data. Hold on. I need to put this back up here. Yeah, we lost some data, so that wasn't even quite right. Oops, I just missed those, so let's take those guys and get them in the load as well. And this is another thing with like serialization, right? Is if you change your format, you have to remember to make the equal and opposite change when you're reading. So min x, min y, or min y, max x, max y. And these are not reals, these are ints. Okay. They should be, right? Int? Yes. Okay, good. So more or less, this is the read structure we're going to use. So I'm actually at a good point to commit right now. And we're going to say this is the prepare in project cache save / load systems. And we have build 125A1. Just gonna go ahead and commit, and we're done there. Excellent. So yeah, it's been fun today. We did quite a lot, although it was a pretty short stream. Tomorrow we will finally implement these into the loading phase loop, and hopefully that just makes it so loading times are just a lot faster because we don't have to process these anymore, except for the very first time when we're creating the cache for these maps. And maybe we can write some kind of mode in my game that says, hey, generate these for every single map and just let it loop through and do all the maps. I think I would like that, and this is a very clean solution because it's all inside the game already. I didn't have to write a separate app to do it. I didn't have to bring any code out from it. I think this makes a lot more sense in how we're doing things. So, we'll be back next time. For those of you that tuned in today, thank you for watching. Hope you enjoyed, and we'll see you next time. Bye.